Welcome to a lesson with Dr. Powell. Let's take a look at implicit differentiation. Again, another example. Suppose we had something like x sine of xy, and we want to, and maybe minus x is equal to 2. And we would like to find the, like to compute what dy dx is equal to, and it could be a function of x and y, that's just fine. So what we do is we can think of this, all right, and and essentially that minus 2 didn't really matter, but whatever. We have fxy, and so we compute fx, fy, and notice we're plugging in x and then y, which depends on x, thinking of this as a vector dependent on one thing. And so taking the derivative of that, derivative with respect to x, would give us 1 dy dx. Using the dot product, we get fx plus fy dy dx. And again, we want this to be equal to 0 because this relationship, the relationship that we want with this equation being set to 0 is the relationship between x and y that we get when we compose this in. So the derivative under that assumption of this composition should be 0 because this value shouldn't be changing the equation, should be what it is the whole time. So you get that being 0, you solve for dy dx, and you get negative fx over fy. Okay, so then we just got to compute what fx is. So partial with respect to x. Well, we have a little product rule in there. So we got sine xy. So because the derivative of x is 1, and you got to take the derivative of sine xy. Derivative of sine of xy, so x times cosine of xy, but then you have to take the derivative of xy, which we can do by and so we're taking the derivative with respect to x. Well, that means that y is a constant with the partial, because I'm just taking fx right now. Okay, so so that means the derivative of xy is just simply y. All right, okay. Then we have the derivative of that is just minus 1. All right, that's what fx is. Now let's do fy, and then we have a negative of all that. Now let's do fy. So fy, we'd come in, and this is just a constant, and we have sine of y times a constant. So the derivative of this is just simply so the constant times cosine of xy, but then multiplied by the derivative of xy, which would, with respect to y, which is just x if x is a constant, and then the rest is just a constant. So we end up getting so we just end up getting that. And this right here is our dy dx. And so just all in one shot, we got what the derivative is implicitly using chain rule. Thanks for watching.